Section 4 of Chapter 3. We're going to solve linear equations in 3 variables. So this is a bit more complicated. This actually takes a good amount of time, so please pay attention step by step on what to do here. Okay? So if I give you 3 equations and 3 variables, x, y, z, this takes a little bit of time. What we're going to do is we're going to use elimination, kind of like what we did before, only more involved. So here's what you got. You can't eliminate all 3 at the same time. So what we're going to do is your step 1 is doing this, taking any 2 equations and eliminating one of the variables. So should we eliminate x? Let's just look at the first 2. Would it be easy to eliminate x? Yeah. Y? A little bit more, because we'd have to multiply both equations, and we'd have to multiply both equations to eliminate z. So therefore I'm going to go for x. Alright, let's get these numbers the same. So let's multiply this whole equation by 2, right? So if I multiply this whole equation by 2, I'll get 4x and 4x. Okay, so I'm going to rewrite them over here. This takes a lot of space. 2y plus 3z equals 1, and then I'm going to multiply everything by 2. Don't forget everything. 4x minus 2 times 3y, 6y plus 2 times 5 is 10z equals 2 times, people forget this, 2 times negative 14, negative 28. You make one little mistake like that and it ruins the whole problem, so please be careful. Next, we want to eliminate x's here, so we'd have to subtract, right? So we subtract these equations. 4 minus 4, we eliminated x, nothing. 2 minus a negative 6, 2 plus 6, 8y. 3 minus 10, which is minus 7z, equals 1 minus negative 28, which is 29. Okay, what we call this is new equation number 1. Alright, that's part 1. Part 2, take any other 2 equations. Doesn't matter if it's first and the third one, second and the third one, any other 2 equations, and eliminate. You have to eliminate the same variable. So I'm going to take the first, actually it'd be easier to take the second and the third. Why? Because that's 2x, 6x. I'd only have to multiply by 3 up here to make them both 6. Okay, so I'm going to take the second and the third equation and rewrite them down here. Actually, I'm going to take this one and just rewrite it. 6x minus y plus 4z equals negative 1. I'm going to take this one, I'm going to multiply this one by 3 now. Okay, so I'm going to multiply by 3 so that I can get 6x right here. Everybody understand that? We're trying to eliminate x, so I got to multiply this whole thing by 3. So 3 times this, there's my 6x. 3 times minus 3y minus 9y. 3 times plus 5z is plus 15z equals 3 times minus 14, that's negative 42. Now I have another system of 2 equations, but I need to eliminate by, in this case, these are both 6, so I have to subtract. Okay, now 6 minus 6, nothing. We eliminated x, perfect. Negative 1y minus negative 9, so negative 1 plus 9 is 8y. 4 minus 15, that's negative 11z equals negative 1 minus negative 42. Negative 1 plus 42 is 41. This is new equation number 2. Alright, so step 1, take any 2, eliminate a variable. We chose x. Okay, eliminated x. Step 2, take any other 2 equations up here and eliminate the same variable. We went for x again. Now look what we have. We have a new system. We have this, 8y minus 7z, and 8y minus 11z. And what we're going to do is we're going to put those 2 together and solve those 2. So 8y minus 7z equals 29. And then we take this one, new equation number 2, put it underneath. 8y minus 11z equals 41. Now what we're going to do is we're going to solve this system. You're going to use elimination here. We're going to eliminate one of the variables. What's the easiest one? Obviously 8y and 8y. We're going to subtract. 8y minus 8y, nothing. Negative 7 minus negative 11, that is positive 4z, equals 29 minus 41. That is what? Negative 12. Look at what happened. We're getting z by itself, which means we're getting ready to solve this thing. Divide by 4. So z, we found z equals negative 3. So if you messed up here and you got z is 4, z is something else, and you plug it back in, you're going to get some crazy answer. So you got to be thorough in what you're doing. Right now, we label every ordered pair, not pair in this case because it's x, y, and z. So right now we have our answer is negative 3 is z. We're going to get y and x. How do we do that? We plug z back in. Where would you do it? Could we do it up here? We could, but we'd still have x and y missing. So we have to do it actually in here, because if we put z here, we have y, we can solve for y, right? So we're going to take z, plug it in, 8y minus 7 times z, which is negative 3, equals 29, solve. 8y plus 21 equals 29, minus 21, minus 21, 8y equals 8, which means y equals 1. There is y equal to 1. We need x left over. So where do we go for x? We have to go up to one of the originals. So let's take the first one. Okay, so not a lot of space here. So 4 times x plus 2 times y, which we know y is 1. So 2 times 1 plus 3 times z, we know z, it's z equals negative 3. So put it in, equals 1. Everything is here except for x will solve. 4x, that's plus 2, that's minus 9, equals 1. So that's 4x plus 2 minus 9 minus 7 equals 1. Plus 7, 4x equals 8, which means x equals 2. We got x, we put it in. There you go. This is your solution to the whole system. If you plug in these three numbers into this equation, it'll work, it'll check. If you plug it in here, it'll check. Plug it in here, it'll check out. Okay? This solution works for every single one here. So, long process. You got to understand it. Okay? So, take your time and try one by yourself.